If you are like me, you probably spend a good bit of your time thinking about your strengths and your weaknesses. It's important to remember what your strengths are because your strengths help you build confidence and help keeping you go forward. Because if you spend too much time thinking about your weaknesses and just constantly beating yourself up, then there's no benefit to that. That's just kind of self-abuse at some point. But you do need to identify what your weaknesses are, because the only way you can become better at something is to deal with them in a healthy way. So that really includes asking for help when you need it, admitting, saying, okay, yes, I am weak. I understand that other people don't have this weakness. They can deal with it. And I have enough maturity and humility to swallow my pride and ask for help, because that's how you get better. You have to admit that some people they have skills that surpass yours, at least in like that respect, because everyone has their own shortcomings. There are things that, I am pretty strong in that other people are weaker in, but the reverse is also true. So it is kind of a collective effort of getting better. I wouldn't be able to get here if it wasn't for a number of people helping me with my math and science. So I guess I would tell a few stories about great humility moments, like moments where my weaknesses were put on display and I really did have to deal with them without moving forward. The great humblings, we'll say. We'll call these great humbling moments. And part of the reason why I've decided to make the video now is because I wouldn't say I had one of those moments today, but I did do a homework problem that was given 2 days ago. So it was given 2 days ago. The instructor said it was easy. I'm like, okay, I can do an easy problem. I have priority, so when I go up to the board today, I should be able to get this problem lickety-split and not worry about it. Well, I didn't have a lot of time to work on it yesterday. I probably spent maybe an hour on it, and I wrote something down, and I was pretty convinced in that moment that my solution was correct, and I didn't think about it twice. And then today, I was looking over my work, and I was like, something in here doesn't really fit well or sit well with me. And sure enough, when I was presenting it, I just absolutely, I didn't say I screwed up, but I got it right up to about the halfway point, and then the issue arose. And I had to essentially freestyle it at the board, and then I got stuck, and then other people in the room had to help me. And eventually, the homework problem was solved. This is it, so I will be discussing it at the end of the video. So essentially, how am I dealing with this great shortcoming? I won't call it a great shortcoming, but it did kind of bother me that I screwed up such an easy problem. And this is more or less me publicly flogging myself, metaphorically speaking, so that I own the problem and I have made up for my mistake. I guess this is one of my ways of dealing with it. It's not the only way, obviously, but it is a way I've chosen to deal with it. Also, you get negative criticism from other people. It's not enough just to criticize yourself. You understand what your weaknesses are, but sometimes you do need somebody that is respectable telling you, like, you're weak in areas X, Y, and Z, and you should work on that. And it's like, okay, I understand. Because there's really kind of two types of criticism, and I get this from people commenting on my YouTube videos too. When I read the comments, the vast majority of them are positive. And then a couple comments will be negative. And I divide those comments into two camps. The first camp are just internet trolls. Those criticisms don't even bother. They don't even faze me, because I've had people that I respect, whose opinions matter to me a great deal, that have told me directly to my face that I suck. Not that I suck, but like, you're really weak in this and you do weird stuff here and you need to stop doing that. And then you're just kind of standing there listening to it like, I'm going to bust into tears. So if you can deal with something like that straight to your face, then, a stupid comment that says, you have fat fingers, that's not going to bother me, like, even a little bit. Like, I know what my fingers look like. I don't care. Those don't even faze me. The ones that I pay closer attention to are people that comment, like, they say, okay, here's my constructive criticism with what you've done, and here's basically some sort of critique of it. It's not just like them saying you suck. It's like they give you an outline of why they're making their criticism. And if it's valid, and I read it to myself and say, okay, this is a valid criticism, I have to be able to swallow my pride and fess up to my mistake. Because you'll instantly lose respect for yourself if there is a legitimate criticism in the room, in a PhD program. If you make some claim and there's a problem with it, and someone points out like, hey, there's a problem with this, you should deal with it, and you go, no, I don't have to do it, and you just bury your head in the sand, that is a very quick way of losing respect. You cannot do that. If you do that, you're not going to go far, unfortunately. Well, not unfortunately, you definitely shouldn't bury your head in the sand. But dealing with it requires a certain level of maturity that if you can't deal with it, then probably you're not supposed to be in a PhD program. It's also just a healthy thing to do, be able to take criticism. So some humbling moments that I've experienced, I guess the first one was when I took math proofs at the university level. I took it at the university level because I took it as an independent study before that, and it didn't go very well. I got a passing score, but it did not prepare me for the world of real analysis and modern algebra. So I took math proofs again. The class was a lot more rigorous and a lot tougher, and I walked into it thinking like, I'm a straight A student in math. I can get A's on everything. And then he would give out homework, and I was consistently getting C's and D's on the homework. And thankfully, he did let me redo the homework. Like if you screwed it up, you could redo it, submit it again, and get a better score, which is usually that's how I ended up getting an A in the class, is because he just let me do my homework over and over again until I got a good score. But I remember I said something really passive-aggressive to him once because I was annoyed at him giving me C's and D's all the time. Like I was blaming him for my poor score, and he didn't really realize it at the time because it was passive-aggressive. But like the next day, I could tell that he realized how rude I was. Like I was rude. I was really young at the time too, so that's my excuse. But I've matured since then, and then after I kind of burned that bridge with him, I wish I could like reach out to him and just say, hey, if you remember me, I would like to apologize. I haven't done that, but I think it's kind of one of those things that you just have to, swallow your pride and move on and try and not do that in the future, because I think that's the only real thing that I can do right now is just not do it again. So that was the first humbling moment I had. I was like, okay, that was rude of me. I shouldn't have said that. I should be more respectful. And then, I ended up leaving mathematics because I didn't think I could handle it. And I guess the second great humbling experience was when I was taking advanced linear algebra. I had decided to go back into math as a non-degree seeking student. I just took the one class. And the first test went well. I had studied for it. And I had studied, I wouldn't say it was great studying, but I was able to do the math that was on the test. And then the second exam, my studying habits did not change, but when I ended up taking that second test, it was really hard. And I remember after it was over, I texted my two friends in the class. I said, hey, what did you think about that linear test? And they said, oh, I thought it was challenging, but I think I got a good score. I was like, oh, okay. So that made me feel a little bit better because again, I went into that classroom thinking that you're like, oh, I'm one of the best math students in the class. And then we got our scores back, and my two friends, I think, either got a high B, low A. I can't really remember what their scores were. But I think I straight up failed that test, and that really upset me. Like, I studied for it too. Like, if I failed without having studied, then I'd be like, okay, I didn't study. I deserve to fail. But I studied for that test, and I still failed, and that really upset me. In fact, I went to the chair of the environmental science department, who I knew at the time, and I kind of told him how I felt and how I was really upset, and I thought maybe I should just stay in environmental science because it felt like I got burned twice with mathematics. And he offered me some pretty helpful advice. He goes, look, just because you fail one test, like, yeah, you studied. You studied for the test and you failed. Sometimes that happens. Sometimes you take a test and it doesn't really matter how hard you study for it. Sometimes the planets will align just to take a fat dump on you. Sometimes that happens. If it happens all the time, then the problem is most likely with you, but sometimes it is the test. And so that kind of made me feel better. He told me to keep at it and keep going. If you love math, you'll figure it out. So the thing I did immediately after that was, like, we weren't even having a test. Like, I just decided to open up the linear algebra book and just go through it again. Just look over the sections that were on the test and just read through it and, like, ask myself, how come I didn't understand this? And eventually, when we had the next class day, after he had graded everything, he did offer a number of us, including me, a makeup for that second exam. So I thought to myself, like, do not screw this makeup exam. Do not screw this up. You need to own up to your mistake and redeem yourself. So I studied. I thought I was studying hard before, but this was like the first time I truly studied. Like, I proved all the theorems in the book. I did a bunch of exercises and homework problems just to make sure I understood what was going on. And then I went in and took the makeup exam, and it went much, much better. So that made me feel really good about myself. And it also, humbled me in that moment too. And I guess the third great humbling moment is already recorded on the channel. That's when I failed that first qualifying exam. Although I was pretty self-aware of my shortcomings, but I was still, I guess you could say I was in denial. I was like, I'm going to walk in there and do really well in that test. And then as soon as I saw it, I was like, nope, I'm not going to do well in this test. But I still wanted to believe I would. But I won't go into great detail because I think I've already explained my feelings toward the qualifier. The first thing that you learn when you enter a PhD program in mathematics is that you weren't as good at math as you thought you were, and that's okay. Because I do see people that are in the program, not the program, but lecturers, people that have written X number of papers and have made pretty substantial progress to solving some open problems, like great open problems. I sometimes see them make simple algebra mistakes and not see it immediately. So if they do that and are able to deal with it, then you definitely should be able to. It's a good thing to keep in mind whenever you're doing a math problem and you make some sort of mistake. So that's what I have to say about negative criticism and how to deal with it. Like, you can take from it what you will. I don't like giving too much advice, but I do like to tell stories about, like, this is a time where I dealt with it, and here's what I did, and maybe it can help you too. Anyway, that was enough rambling. Let's look at the homework problem that I absolutely botched. I won't say absolutely botched. I got to be honest with myself. Like, I understood what I was doing up to a point, and now I believe I've owned up to my mistake. So this is homework problem 45 in the class. We are studying Hilbert transforms and other transformations in Fourier analysis. And this was the problem that we were asked to do. You have a 1 Lipschitz function on the real numbers that's non-negative. We denote it with phi. You define a kernel k sub phi to be equal to some given kernel k of xy, times this fraction. So I'll let you read it here. And I believe the name of this function, he said, was the Calderon-Zygmunt kernel, although I could have misheard him, but I was pretty sure that's what he called it. And the kernel k is not written explicitly here. It's in our notes, but you don't really need to know exactly what it looks like because we just need 2 properties about it. So the first property is that k in absolute value is bounded above by 1 over x minus y, and the gradient of k with respect to x and with respect to y. So the notation here is a little bit ugly to look at, but that's what it means. I was just saving ink in my pen at this point. That gradient is bounded above an absolute value by 1 over x minus y squared. And we want to show that the gradient of k sub phi with respect to x or with respect to y is bounded above by some constant times 1 over x minus y squared. So this is the homework problem. And for the most part, this homework problem looks just like what we did in class in our notes. So I kind of copied that. And then eventually the problem comes down to estimating 1 fraction. And I'll show it to you when I get to it. So just so you're aware, the definition of 1 Lipschitz means that for any real numbers x and y, we have that the absolute value of phi x minus 5y, is bounded above by x minus y. This is the definition that he used. And by the symmetry of x and y, it is enough to show just for the case that we have gradient with respect to x is bounded above by c over x minus y. What I'm saying is that the arguments for these two guys are the exact same. You just replace x and y with each other. So if you do it for one, you automatically have the other one for free. So we do it with respect to x. We take the gradient with respect to x of k sub phi, and we essentially just do the product rule. So you have gradient of k times the second function plus the first function times the gradient of the second function. Now the gradient of k with respect to x, we assumed is bounded above an absolute value by 1 over x minus y squared. And that will cancel with one of these guys on top. And because phi is a non-negative function, we can make the fraction bigger by removing the two phi's in the bottom, which means that this first fraction here, this first product, is bounded above an absolute value by some constant over x minus y squared. So the first fraction here is taken care of immediately. I don't have to do anything with it. And for the second one, we have k of xy is bounded above an absolute value by 1 over x minus y, which is fine. But this requires attention or investigation as I've written it. So we need to calculate the gradient with respect to x of this fraction. So I defined f of xy to be this guy, and I rewrote it in a way that I could avoid using the quotient rule. There's nothing wrong with the quotient rule, it's just I didn't really want to deal with it. It's just I like the product rule and the chain rule better. So I rewrote it this way, and then I simply differentiated and I took the gradient of both sides and took absolute value. So, product rule and then one round of the chain rule. And you can pause the video and read through this here, but there's just calc 1 here. There's nothing else here. There's just calc 1 here. And that does say derivative of phi with respect to x at the bottom. And I also sandwiched in x minus y squared here because I ran out of room. Okay, so we can rewrite the gradient with respect to x as follows. I just split it up into two fractions. Well, okay, I didn't split it up into two fractions. I just rewrote it in a more visually friendly way, I guess. And then if I multiply both sides by k of xy, and because I know k of xy is bounded above by 1 over x minus y, I can do some reducing. So this first fraction, this guy on top will cancel. So I end up with 2 over x minus y squared plus the two phi's. And because the two phi's are, again, non-negative, I can make the fraction bigger by just removing them. And this becomes of the form c over x minus y squared, which is exactly what we want. So there's nothing wrong with this first fraction. The second fraction, again, we have 1 over x minus y here. So 1 will cancel on the top here, so I'm left over with 1 here. This guy requires more of our attention. So we denote him with this smiley cat face. The reason I wrote it this way is because my advisor likes to denote things with cat faces. So if I want to estimate the cat, I can split this fraction up into two pieces. So the first bit is distributing x minus y to this bit where my index finger is. So we get something that looks like this. So in the top you have x minus y squared, and in the bottom, again, you're applying the same trick. You can ignore the two phi's. So you have x minus y squared squared, which is of the form constant over x minus y squared. So again, this fraction is good. This guy is the troublemaker, what you have left over. So after distributing the x minus y, you have x minus y times phi of y times derivative of phi with respect to x over the denominator with second power. Because phi is Lipschitz 1, we know that phi prime of x is bounded above by 1 by assumption. So I can pretty much put my thumb over it and ignore it. And then you need to split this guy up into two cases. And this is where I really started to fall apart at the board, and I didn't really understand, and this is what I had to reckon with. You have two cases. The first case is what happens when x minus y is bigger than phi of y times 2. And the second case is what happens when 2 of x minus y is less than or equal to phi of y. So why is the 2 there? Well, it becomes useful for us in the end, and you'll see why here in a second. This is the part of analysis that's kind of annoying, starting at the end and working your way backward. So in the first case, if phi of y is bounded above by 2 times x minus y, then for this fraction, I can just replace this guy with this guy to get an estimate. And that gives me 2 times x minus y squared over denominator squared. Again, I can ignore this. So I have x minus y squared over x minus y fourth, which is of the form c over x minus y squared. So again, I probably should have mentioned this a long time ago, but the c just represents some arbitrary constant. So in case 1, everything's fine. Case 2 is where you need to employ the reverse triangle inequality. So in case 2, if phi of y, if we add and subtract phi of x, then we can get something that looks like this. This is just from a triangle inequality estimate. And then subtracting phi of x from both sides, we get phi y minus phi x is bounded above by phi x minus phi y in absolute value. And by Lipschitz, you know that this is bounded above by x minus y in absolute value. And then, because we know that phi of y is bounded below by this amount, we can estimate from below again and get 2 times x minus y in absolute value minus phi x. So you have this string of inequalities. And the next thing I'm going to do is move this over here. And if I do that, I will get negative phi x is less than or equal to negative x minus y. And then multiplying both sides by negative 1, we get phi x is bounded below by x minus y. All right. So using these two estimates of phi x and phi y, we can get an estimate for the troublemaker. So for the troublemaker, if you don't remember what it looked like, we have x minus y times phi y over x over quantity squared. And what we can do, again, is ignore this time the x minus y squared. Previously, we ignored these two, this product, and just worked with this. But now we're going to ignore this and just look at phi x, phi y. So by doing that, we get this estimate. One of the phi y's will cancel. So this looks like this here. And now I'm going to substitute in the lower bounds for phi x and phi y, because when you replace the denominator with something smaller, you get a bigger fraction. So by doing that, we will get this, and then replacing phi y with 2x minus y, we will get this. And so we have x minus y cancel with one of the x minus y's in the bottom here, which gives us a fraction of the form c over x minus y squared. And that pretty much completes the proof. I kind of went through that kind of ugly, I'll admit. But I wrote this up from memory right before I made this video. But I think I included all relevant details. This was more or less what we did at the board together as a class. So if you have any comments, if I made a mistake, I can deal with it, obviously, after making this video. So I will be looking forward to those in the comment section.